Alright, back with part 3. Let's keep going. So this one over here, well, I've got a bit of simplification I can do first, don't I? I've got 12 and 2. That's going to simplify to just 6 over 1. So I really have negative 6 equals n minus 7 divided by n plus 9. This n plus 9 is the real problem, isn't it? We want to multiply by n plus 9. So I'm going to remove that denominator, but of course I can't just multiply one side and hope to maintain equality, so I also need to multiply this other side by n plus 9. And remember, this is negative 6 over there. So what happens when I do that? Well, I'm going to have negative 6 by n is negative 6n, negative 6 by 9 is negative 54, and that's going to equal n take 7. Not so bad now, is it? We're going to collect all our n's on one side, so that's the smaller one, negative 6n, so I add 6n to each side. Opposite of subtracting 7 is to add 7, so I'm going to add 7 to each side. And we're done. Negative 54 plus 7 is negative 47, and that equals 7n, and of course you can divide by 7. Negative 47 divided by 7 is equal to n. Easy as that. 31, same sort of thing, so hopefully you've got the hang of it now. Here, 6 over 8, that can be simplified again, can't it? That can be simplified to 3 divided by 4. Both even numbers divide each side by 2. This time I want to get rid of the denominators again. Always best with these sorts of things if you can clear the denominators, and you do that by multiplying by the common denominator. Now the common denominator is 4 times n plus 8. You can see this one has 4 in the denominator. The right hand side has n plus 8. So now, when I do that, we are going to have a nice expression without denominators. It's going to be much easier to solve. So I'm going to multiply 3/4 by this new term, 4 times n minus 8. The 4's are going to cancel. I'm just going to have 3 times that n minus 8. Now you can write it out if you would like. 3 times n plus 8. I swear I just said minus 8 a couple of times. That was silly, wasn't it? And over here, the n plus 8 term is going to cancel. And I'm just left with 4 multiplied by that n plus 2 that was in the numerator on the right-hand side. Now we can expand and simplify. You could, if you wanted to, have gone straight to this line. 3n plus 24 equals 4n plus 8. But I'm happy if you want to include that extra bit just to make sure you're getting it right. There's nothing wrong with that. Subtracting 3n from each side and subtracting 8, we're left with 24 minus 8 will be 16. 4n minus 3n is n, and we're done. N equals 16. Want to check it? 16 plus 2 is 18. 18 over 16 plus 8 is 24. 18 over 24, well that's 3/4, which is what 6 over 8 was. So we're all good, fine and dandy. Alright. Solve each equation. Remember to check for extraneous solutions. They're just looking for solutions which would be undefined, such as n equals 0. We don't need to worry about that for these ones though, so let's just see how we go. 2 equals the square root of p. Obviously, opposite of square rooting is to square. So I'm just going to square each side, and I get 4 equals p. Nice and easy. This one over here, got a problem with our denominators again. What's our solution there? Multiply by the common denominator. I could, seeing as though these are over n squared, sort them out now. I'm already down the path of multiplying by the common denominator, so let's just do that. So I'm going to multiply everything by 2n squared. The left hand side, well that is the denominator, so now I'm just left with the numerator, which was 1, equals this term here, the n squareds cancel, and I've got 2 times the 3n plus 9. Let's actually expand it as we write this line this time. So 2 times 3n is 6n, and 2 9s are 18. And then I've got the minus, and the n squareds cancel, and I've got 1 times 2 is 2. Nearly there, aren't we? We've got 1 equals 6n plus 7. Subtract 7 from each side, I have negative 6 equals 6n. Dividing by 6, n equals negative 1. And that should be okay. So we're done. Not so. Alright, last little mistake to fix up. You heard it there. Here I was multiplying through, did all the right thing. Cancelled the n squared for the second term, and it was 2 times 3n is 6. But look, 2 times 9, that's an error there. That should be 18, shouldn't it? Should be doing that in red pen too, so you can actually see what it was that I did incorrect there. How's that going to change our final answer? Let's go through. Well, instead of being 9 minus 2, 18 minus 2 is going to be 16. When I subtract 16, I am going to have negative 15 equals 6n. And finally, when I divide by 6, negative 15 over 6, which is, of course, negative 5 over 2. Sorry about that one. Keep going with the rest of the video. Cheers, guys. No bad either. Keep going. Now, we are doing this factorization of quadratics this term. You did actually do it last year, so this was just in there to try and jog your memory of that before you got to it in class. Obviously, some of us will remember and others not so much. Let's just have a look and see what we can do. Remember, factorized expressions are much easier because we can simplify, add, subtract, and do all those things we need to much more easily. So what am I doing when I factorize this quadratic? I'm looking for numbers that multiply to equal 18, that add to equal 9. And obviously in this case it's 6 and 3. Let's just see why that works again. N times n will give me n squared. We knew we had to have that. N times 3 is 3n, and 6 times n is 6n. Add those two together, we get the 9n. And finally, 6 times 3, that's the 18. So that worked pretty nicely. Over here on the right-hand side, well, it's the same expression, so I can just make that n plus 6, n plus 3 as well, because we know that that's the factorized form of it. Now, what do we want to do here? Well, I'm a little bit ticked off by those denominators, so let's get rid of them. Let's multiply by the common denominator. N plus 3, n plus 6. Going through term by term, evaluate and simplify. So this n plus 3, the n plus 3 is going to cancel. I'm going to have 1 times n plus 6. Well, that's just n plus 6. This second term on the left-hand side, the term I'm multiplying is the same as the denominator, so each of those brackets would cancel, and I'd just be left with 1. So n plus 6 plus 1 equals, and again on the right-hand side, both factors in the denominator are going to cancel, and I'm just left with 5. Well, this is not so bad at all, is it? N plus 7 equals 5. Subtract 7 from each side, and I have n equals negative 2. Hopefully you can see how that worked. I know that factorizing might have been a little bit of a problem for you. We're going to cover that again. But the rest of it, especially this key, multiplying by the common denominator, I really want you to be competent and confident with that. That's what we're aiming for. 35, let's have a go. 7 plus a divided by 4 equals 5. Let's rearrange it. Inverse operations, opposite of dividing by 4 is to multiply by 4. So we have 7 plus a equals 4 5s are 20. Subtracting 7 from each side, I get a equals 13. I'm sure you could all do that one. This one here, similar sort of thing. Let's subtract the 2 first. So that's going to be negative 10 equals n divided by 2. Opposite of dividing by 2 is to multiply by 2. Negative 20 is equal to n. And we're done. I might pause there. The videos, I don't want them to be too long, so you have to go searching for what you're looking for. And I'll see you in the next one. Good work, guys. Keep up the great maths.